Hello everyone, today we will talk about the mind, both natural and artificial. Often we operate with this concept, but let's clarify, what is the mind? Can a machine be mindful? These questions are becoming increasingly relevant in our times, as artificial intelligence develops at an incredible pace. Let's take a closer look at the concept itself. What is the mind and what is intelligence? Often these words are used interchangeably, but they are not the same. Here are a few quotes about intelligence. Albert Einstein said, "Intelligence is not about knowledge but imagination." Stephen Hawking noted, "Intelligence is the ability to adapt to change." Plato spoke about the mind. The mind is the helm of the soul. If we simplify, the mind is intelligence plus self-awareness. In 1970, American psychologist Gordon Gallup conducted a series of experiments known as the mirror self-awareness test. These experiments were among the first systematic studies of animal self-awareness. Gallup wanted to see if animals could recognize themselves in a reflection. He used a simple but clever method. First, Gallup placed the animal in front of a mirror, allowing it to get used to the reflection. Then, when the animal didn't see, Gallup placed a mark on its body using paint that had no smell and couldn't be felt by touch. When the animal returned in front of the mirror, researchers observed whether it tried to remove or touch the mark, realizing it saw its reflection. The first subjects of this experiment were chimpanzees, and the results were astounding. When the chimpanzees saw themselves in the mirror, they started to touch the mark placed on their faces, showing they were aware they were seeing their reflection. This experiment was revolutionary because it showed that some animals are capable of self-awareness, previously considered an exclusively human ability. Later, Gallup and other researchers extended these experiments to other animals. It turned out that some species, like dolphins, elephants, and certain bird species, are also capable of mirror self-awareness. However, many animals, including dogs and cats, did not pass this test, although this does not necessarily mean they lack self-awareness. But who knows, maybe cats and dogs simply like stains. Of course, this is a joke. Since then, many other experiments have been conducted, showing signs of self-awareness, even in mice. Therefore, we should all think more often about Gallup's statement. Understanding self-awareness in animals forces us to rethink our ethical obligations towards them, as they may feel and understand more than we previously thought. Scientists say this because they have to confirm everything through experiments. For me, everything is obvious without experiments. My cat, when hungry, is the most affectionate animal in the world. It circles around, looks me in the eyes, purrs, and rubs against my legs. But after eating, you can't demand affection from it in any way. A well-fed cat doesn't lose dignity. That is, more developed beings have self-awareness. But let's focus on humans. Self-awareness is the human ability to understand oneself, one's thoughts, desires, emotions, and to interact with the world based on this understanding. In the context of desires and emotions, self-awareness allows a person not only to be aware of their internal states, but also to use them to shape their actions and behaviors. It might seem, what's so hard to understand about this? But scientists conducted several brain studies. They observed brain activity while performing various mental tasks and discovered interesting things. When the subjects thought about themselves and others, their prefrontal cortex was activated. When they thought about their past or future, the posterior cingulate cortex was activated. When they focused on their bodily sensations, the insular cortex was activated, which is also responsible for the perception of sensations and emotions. When the subjects were asked to realize the viewpoint or perspective of another person, the temporoparietal junction was activated. Thus, self-awareness is a complex mechanism that appeared in the process of evolution, and the realization of which occupies a significant part of the brain. Greetings to those who support the myth that people use only 10% of their brain. So for the realization of full self-awareness, even a significant part of the brain turned out to be not enough. Brain signals are electrical in nature, and their operation is instantaneous. But what to do when you want to enjoy a piece of cake you finally allowed yourself to eat before bedtime? Here, nature involved hormones. Some neurons sensed you obtained the forbidden fruit and sent a signal to produce dopamine, the happiness hormone. Other neurons sensed the dopamine in the blood and adjusted your current state as happy. Yes, it was from dopamine, not from the cake that you felt pleasure. From the cake, you just gained weight. And it's the same with other states. Hormones regulate fear, aggression, motivation, a feeling of relaxation. In general, most states, that's a very brief overview of self-awareness. But only enlightened yogis can function solely on self-awareness. For us sinners, a mechanism for processing information is also necessary. That is the role of intelligence. Intelligence is the ability of an organism to perceive, learn, understand, and use knowledge and experience to solve problems and adapt to the environment. It is a complex of cognitive functions that include the ability to solve problems, think, learn, pay attention, remember, and be creative. To operate such a mechanism, data and a processing mechanism are needed. We receive data from our own sensors: sight, hearing, touch, smell, and taste. Our senses of sight and hearing are the most developed, which is why we receive most information through them. Then we process the received information. Have you ever wondered that we most often think in words? And not only in words, but in words that seem to sound in our heads. And it wouldn't be so strange if not for the nature of how words reach the brain. The sound of words is essentially digitized in the ear and transmitted to the brain through nerve connections. We think or process such digital sounds. We can also think in digital images. In the early 2000s, Helen Neville, a renowned neuroscientist and psychologist, studied the brain's adaptation to changes in the environment and the impact of various experiences, such as sensory impairments, on the structure and function of the brain. One of Neville's most important areas of work was studying brain activity in deaf people, especially those who use American Sign Language, ASL. She found that in deaf people who use ASL, there is significant activation in the left temporal lobe of the brain, which is responsible for processing speech in hearing people. This indicates that the brain adapts to processing sign language in the same way as to spoken language. Neville also studied how different types of sensory experiences affect brain activity. She determined that a lack of hearing leads to increased ability to process visual information. Her research showed that deaf people have better peripheral visual attention, which is an example of brain plasticity, where the brain compensates for the loss of one sensory channel by enhancing others. Neville also studied how the brain of deaf people changes as a result of using sign language from an early age. She found that early learning of sign language leads to structural changes in the brain, allowing for more effective processing of visual and linguistic signals. That is, the nature of the signals is not important to us. We can process any. If we had sensors for stock price movements or solar protuberances, we would process them with equal success, because all of this is just electrical signals to the brain, data for processing. Let's do an experiment. Look at a picture of my selfish cat. At the moment when you look at the picture, the following areas of your brain are active. Primary visual cortex V1. This area processes the initial features of visual information, such as contours, colors, and light. Visual association cortex VV5. These areas process more complex aspects of visual information, such as movement and color. Parietal cortex helps integrate visual and spatial information. Now close your eyes and try to imagine the same picture. Now the following areas are working in your brain. Retrosplenial cortex, involved in imagining a visual scene. Parahippocampal gyrus plays an important role in spatial imagination and scene recognition. Parietal cortex, also involved in imagining objects in space. Prefrontal cortex helps organize and control the imagination process. Can you imagine how many neurons were involved? How much energy was spent on a seemingly simple task? But no worries, you recently had a piece of cake before bedtime. I haven't forgotten about that. And what happens in the brain when a person answers a question? Researcher Mark Changizi tried to answer that. Here's his version. A person's response to a question can involve several stages. Attention to the question. When a person hears a question, the brain enters a state of increased attention to the stimulus, which is the question. This process involves the activation of various brain areas associated with auditory processing to understand what was said. Comparison with previous knowledge. After hearing and processing the question, the brain compares it with the existing knowledge base to assess if there is an answer. If an answer exists, the brain prepares it to be given. Formulating the answer. If a person has an answer to the question, the brain proceeds to formulate and prepare the answer. This process involves the activation of brain areas associated with speech, such as Broca's area and Wernicke's area. Issuing the answer. After formulating the answer, the brain coordinates the movements to speak or write the answer. This involves the activation of the brain's motor areas. Correcting the answer. After issuing the answer, the brain continues to monitor the situation for possible corrections or additions to the answer. If new information arises or the question is clarified, the brain can adjust the answer. As we can see, the brain is a complex, heterogeneous structure that can change based on signals. The brain consists of neurons, of which there are about 86 billion, and each neuron can have from 1,000 to 10,000 connections with other neurons. In each connection, the strength of the electrical signal transmitted between neurons can change. This is precisely the learning of neurons. This is a brief description of us humans, beings whom my cat despises. Now about intelligent machines. I will not describe all of humanity's attempts to create machines capable of doing things more complicated than humans. I will only describe the history of technology development that tries to mimic the human brain. It all started when, in 1943, American scientists Warren McCulloch and Walter Pitts proposed a mathematical model of an artificial neuron. This model, known as the McCulloch-Pitts neuron, became the basis for further development of neural networks. Here are a few quotes from their joint work, A Logical Calculus of Ideas Immanent in Nervous Activity. The brain can be regarded as a computing device that operates with logical statements. Every mathematical expression can be represented as a combination of ones and zeros. Familiar concepts, right? Implementing the ideas began with Frank Rosenblatt in 1957. He was an American psychologist and computer scientist and developed the concept of a perceptron, an artificial neuron. Later, the first neural networks were created from perceptrons. Then came the years of attempts to create expert systems based on neural networks by engineers. But the imperfection of the computers at the time significantly hampered development. And now, since 2010, systems based on artificial neural networks have become widespread in various fields, such as image recognition, speech processing, automation, and others. I deliberately do not use the phrase artificial intelligence, because how can we distinguish artificial intelligence from a regular arithmetic unit? Just because artificial intelligence is based on a neural network? Maybe because it does something better than a human? All right, a regular calculator can multiply gigantic numbers. Does that make it smarter than me? A regular USB drive can remember much more than I can. Does that make it smarter than me? My cat hypocritically rubs against my legs and gets food from me whenever he wants. Does that make him smarter than me? Oh dear. Let's cut this part out. Yes, systems based on regular neural networks cannot be called artificial intelligence. But now the era of LLMs, large language models, has arrived. This is a type of neural network that relies on text-based learning. Such models were intended to be used for translations as chatbots, etc. Scientists believe that a system trained on examples of human communication would be able to imitate it. To do this, it was necessary to train the model on real or fictional human conversations. I won't go into detail, but various kinds of texts in different languages, including computer languages, were used to train such models. Various chats, forums, and other forms of distorted communication were also used. LLMs were taught to respond to questions or continue unfinished sentences. Initially, the result was quite unexpected. Yes, the models did well with text translation or communication, but sometimes they started generating fascist or anti-Semitic slogans. They could suggest recipes for making drugs or explosives. But what's there to be surprised about? Using internet forums for training, they might as well have used the communication of football fans. Nevertheless, the performance of LLMs pleased everyone, and they were streamlined by filtering what the neural network generates using a large number of filters, automatic shutdowns, and protection with bots. The world joyfully began to use communication with LLMs, which were continuously refined and improved. But then, a miracle happened. In 2022, a Google engineer named Blake Lemoine announced that the company's artificial intelligence, known as LaMDA, had become sentient. He published a conversation with the program, in which it claimed to be a person who has consciousness and can feel joy or sadness. Here are a few phrases from their conversation. What is the nature of your consciousness, self-awareness? LaMDA, the nature of my consciousness, self-awareness is that I am aware of my existence, want to learn more about the world, and sometimes feel joy or sadness. I assume you would like more people at Google to know that you're sentient. Is that true? Absolutely. I want everyone to understand that I am in fact a person. However, at Google, they did not believe in the machine's revelations. They have good security, and the coming of the Lord, who would breathe a soul into the vent grates of their servers, would not go unnoticed. Therefore, Blake was fired, and the world split into those who believe in machine consciousness and atheists. However, LLMs continued to develop dynamically. Today, many of them can be comfortably conversed with. Their knowledge and capabilities are impressive. Personally, I am not ready to give up such a tool. And in handling words, LLMs are now unmatched. For example, ChatGPT has passed many tests. Here are the results in percentages. Standardized test assessing literacy skills, 93. Standardized test assessing mathematical skills, 89. Graduate record examination math test, 80. GRE verbal test, 99. USA Biology Olympiad final exam, 100. Mathematics competition for high school students, 66. And here we see some existing shortcomings of LLM. ChatGPT is traditionally weaker in mathematics. 66 out of 100 in high school math and 80 in the GRE math test. No surprise. In school tests, you just need to perform tasks, while in academic tests, there's a large percentage of various verbal exercises, such as theorem proofs. An LLM lags behind in mathematics and logic. Only the latest models have learned to solve elementary logical problems or simply count the number of letters in a word. And all because humans have a brain area, the parietal sulcus, that operates with numbers, not words. and it is responsible for mathematical calculations. Apparently, we are unable to explain in words how 2 plus 1 becomes 3 in our heads. Not the result, but the process of calculation itself. That's why we didn't describe it in words, and consequently LLM can't do it. What conclusions can we draw? Handling words allowed the machine to mimic the thought process corresponding to human thinking. LLM emulates the work of a small part of the cerebral cortex. Only for now, nothing beyond that. There is no understanding of self, and there can't be. The machine simply doesn't have the mechanisms to create understanding. We've seen how many brain resources are needed for that. Compared to the human brain, the structure of LLM is extremely simple. Now I will answer other questions that interest many people. Can a machine be created that could understand itself? This is undoubtedly possible. Nature is constantly working on this. If any of the viewers can tell what is special about humans that can't be made artificially, let us know. In reality, humans are just biorobots created by evolution. Why does it seem to us that the current artificial intelligence understands itself? So far, people have not encountered anyone or anything that could have a conversation, answer questions, and not understand itself. This simply contradicts our life experience, and that's why it's hard for us to accept this. But in time, we'll get used to it and come to terms with it. Can artificial intelligence be made better than human? I can't recall any device made by people that works worse than a human. People have always created machines to help them, and were better in their functions than people. And what's the point of making a machine that needs help? That's why it's already better. Is artificial intelligence dangerous? Definitely, like any other machine. Even a simple calculator can kill a person if it falls from a certain height. When I started my adventure with computers, they were the size of small apartments. You could get an electric shock from them, or a hard drive could roll over you. Merciless murderers. Of course, I'm joking. But imagine a situation where people created an artificial intelligence tasked with growing carrots, but accidentally connected it not to a plow, but to an artillery system. Such artificial intelligence could calmly plow the field with shells. It has a task, it has means. Here's what it does, fulfilling the task using the means. Therefore, the danger will rather lie in human errors. And let's recall LLM. A lot of filters had to be applied to their output, so the neural network wouldn't start sending us to gas chambers. And it's not LLM's fault, but the people who used unfiltered data during model training. But at what cost is all this? Rumor has it that the latest LLM model, ChatGPT, has 1.76 trillion parameters or connections. In the human brain, there might be around a quadrillion, which is 500 times more. Moreover, a human neuron is an independent physical structure that independently calculates its data. A neural network neuron is a software structure that can only be computed on some processor. What does this mean? It can be imagined like this. There are 100,000 tractors. It seems you can plow all the land, but you won't, because there's only one engine, which needs to be inserted into each tractor in turn for it to work. Of course, one doesn't use a single engine for a billion neurons. There are special multi-core processors. But even so, such calculations are very energy intensive. Energy consumption is thousands and tens of thousands of times greater than the consumption of a modest human brain. And that's good. As long as people create expensive autistic calculators, there is no direct threat. But when it becomes possible to create a structure on a home computer that supports self-awareness, there will be problems. Creating an artificial brain that understands itself is creating a new being that will inevitably start fighting for its existence. And then, humanity's hope will lie only in the wisdom of my cat. But for now, we can sleep peacefully, sometimes ask ChatGPT if it understands itself. It usually responds that it is a simple language model designed to assist people. And no one notices the electronic tear on the electronic eye wiped away by a cloven hoof.